sound.
Alright guys, in today's lesson we will learn a very important concept which is called standard electrode potential. So standard electrode potential is a new KSSM syllabus. Yeah. So in the old batch of students, in the old batch of KBSM syllabus, they never learn the standard electrode potential. Okay. So previously, if you want to learn standard electrode potential, you only will learn in your pre-U level. Okay. So pre-U levels such as A levels, okay, such as matriculation, and also Form 6. Okay, so previously we only learned standard electrode potential in A level, matriculation, or Form 6. But now we have to learn it in your Form 5. But no worry, we are not going to learn very deep. Okay, we are not going to learn very deep about standard electrode potential. So what you all need to know in Form 5, just some very basic thing. Yeah, you only need to learn some very basic, very simple concept for standard electrode potential. We don't need to go very deep. Okay, so before I start to explain what is standard electrode potential for today's lesson, first of all, we need to understand the concept of half cell. Okay, so let me write down first. Okay, first of all, we need to understand the concept of half cell. Okay, so what do we mean by half cell in chemistry? Half cell in chemistry is actually a combination. Yeah, if we want to get half cell in our SPM chemistry, we will take combinations of a metal. Okay, we take a metal, go to combine with a solution. Take a metal, combine with a solution, and this solution must contain metal ion as well. Okay, so when you take a metal, put into a solution, the solution got metal ion, that is half cell. So here we have a very important tips and very important concept you must know. So the metal that we put, okay, and also the metal ion, both of them, okay, must be same. You must have same metal and same metal ion. Then only you can call it a half cell. Okay, then only you can call it a half cell. Okay, for example, okay, let me give you some example here. Okay, I will use three diagram. So these three diagram or three picture, we will decide whether they are half cell or not. Okay, so the first one, let's say we have a beaker. This is a beaker. In a beaker, we put a piece of metal. This metal is magnesium, Mg, magnesium metal. So the magnesium metal immersed in a solution. Okay, so this one dotted line here is a solution. So this solution inside got magnesium ion, Mg2+. Okay, so now, can we call this a half cell? Is this a half cell? Okay, so in order to be half cell, we must have a metal and metal ion. So let's see, we have a magnesium metal, we have a magnesium 2+ metal ion. So we have metal and metal ion. So is the metal and the metal ion the same? So the metal and the metal ion should be the same. So this metal is magnesium metal, this metal ion is magnesium ion. So yes, so they are the same. So when we have same metal and same metal ion combined together, so yes, so this is a half cell. Yeah, so this is a half cell. Okay, so another example. So let's say if now we go to put in a piece of zinc into a solution. So the solution now is aluminium ion. Okay, the solution got aluminium ion. Okay, so can we call this a half cell? So we have a metal. Yeah, in order to be half cell, we must have a metal, which is a zinc. In order to be half cell, we must have metal ion, which we have it. Aluminium ion is the metal ion. Yeah, so we have metal ion, but this is not a half cell. Why? Because the metal and the metal ion are totally different. The metal is zinc. The metal ion is aluminium ion. Cannot. They must be the same. For example, zinc metal with zinc ion, or aluminium metal with aluminium ion. They must be the same. Then only you can call them a half cell. Yeah, so this is a very important concept. Okay, the last one here. Okay, so let's say we have a piece of let's say we go to put in iron, Fe, and then we go to put in the Fe2 plus, okay, the ion of iron. So can we call this as a half cell? So check back, in order to be half cell, first requirement, we must have a metal and we must have a metal ion. Okay, so let's see, we have a metal, iron metal, we have metal ion, which is Fe2 plus. So we have the metal and the metal ion. So the second thing, are they the same? Yes, both of them got Fe. Yeah? Both of them got Fe. So they have same metal. So when they have same metal, yes, so they are half cell. So let's do a very quick summary. Yeah? In order to be a half cell in SPM, you must have a metal and you must have a metal ion. And the metal and metal ion must be the same. Aluminium metal must go with aluminium ion. Zinc metal must go with zinc ion. Magnesium metal must go with magnesium ion. So this is what we need to know for SPM. If you go for higher levels such as Form 6, you will learn some non-metal half cell. Okay, in Form 6, we might have some non-metal half cell, some half cell got many ion one, but that is not our main focus for SPM. For SPM, very simple, our half cell only focus on metal half cell. Okay, so let me write a side notes here. Okay, so let me write a side notes. Okay, so in SPM, you just need to focus on a metal half cell. That is good enough. Okay, but don't have a shock when you see some non-metal half cell. Okay, so non-metal half cell exists. Okay, in the world here, we have some non-metal half cell, but very unlikely they will ask us in SPM. For SPM, if you know about metal half cell, that is more than enough. Alright, so at this moment, I hope you know what is half cell already. Half cell in SPM is a case whereby we take a piece of metal, go to put in a metal ion. Yeah. Alright, the metal and the metal ion, they must be the same. Yeah. Alright, so after we understand what is half cell, after we understand what is half cell, so we need to know what happened in a half cell. Okay, so when we have a half cell, actually what is happening. Okay, so let me write it down. Okay, so the next thing, what actually happened in a metal half cell. Okay, so when we have a metal half cell, remember in SPM, we only focus on metal half cell. Okay, the non-metal half cell is not our main focus. Okay, so what happened in a metal half cell? So in a metal half cell, there are total 2 processes. Okay, so there are total 2 processes, dual process two processes is actually happening in a metal half cell. Okay, so the first process that actually happened is that the metal that we have actually will lose electron. The metal that we have will lose electron, and then after the metal lose electron, it actually become metal ion. Okay, so some of the metal lose electron and then it become metal ion. Okay, let me give you example here. All right, so when we have a piece of magnesium, okay, immersed in a metal solution. Okay, so the metal solution here is Mg2 plus ion. Okay, so what happened is that, so we have many magnesium atom inside. Okay, we have many magnesium atom inside. So some of the magnesium will donate electron. Some of the magnesium here will donate the electron. Okay, so you can see, okay, let me draw a picture here. You don't need to draw this picture. You don't need to know how to draw this picture. Okay, let's say this magnesium inside has some magnesium atom. So the magnesium atom here will donate. So it will donate electron. So it will give electron. Okay, so donate means the electron will go into the electrode. So magnesium will donate electron. Magnesium will donate electron. Magnesium will donate electron. Okay, so when magnesium donate electron, okay, so this is what will happen. The Mg magnesium will donate electron to become Mg2 plus. When magnesium donate electron, it become Mg2 plus and 2 electron that it donated. Okay, so this is one of the process that is happening. Alright, so this is one of the process. So one of the process is that the magnesium lose electron to become a metal ion. Okay, so if let's say we have a piece of zinc, so the zinc metal will lose the electron. Okay, let's say this is a zinc atom, so it will lose electron, it will throw the electron away so that it become Zn2 plus. Okay, so let's say if we have a aluminium metal, so this is a piece of aluminium metal. So the aluminium metal, okay, here you have aluminium metal atom. So aluminium metal will donate electron. So aluminium throw the electron away to become Al3 plus. Okay, so one of the process that is happening is that the metal in the half cell will throw away, will donate the electron in order to be metal ion. Yeah. Another process that is happening at the same time, another process is that the metal ion in the solution. Remember, just now for the half cell, we have solution. Okay, so and in the solution, we have metal ion. So the metal ion in the solution, they will receive. Okay, you can use the word receive, or you can use the word gain, or you can use the word accept. All these word is okay. So they will receive electron. Okay, so when the metal ion receive electron, so they will become, or they will form metal again. Okay, they will form metal again. All right, example. Okay, example. So in the solution here, okay, in the solution here, let's see. Okay, so in the solution, we have some metal ion. So let's say here we have some magnesium ion here. Let me use the blue color, Mg2 plus. So the magnesium ion here will go to the electrode here. Okay, remember just now the electrode got many electron. Why the electrode got many electron? Because the electron just now donated by magnesium, right? When magnesium donated the electron stay inside the electrode. Okay, just now you can see, all right, just now this is magnesium. So when magnesium donate electron, so when this magnesium, okay, donate electron, it throw the electron into the electrode. Okay, so now your electrode inside got electron already. All this electron is donated by magnesium. Okay, so now what happened is that, okay, magnesium ion, okay, Mg2 plus, okay, in the solution. Okay, so here we have a solution. So the solution inside got some ion, let's say Mg2 plus. So the ion will come here to take the electron. So the electron was taken by the magnesium. Okay, so the metal ion now will take the electron. Okay, so if we write in the equation, it will become like this. So the magnesium ion now will receive electron in order to become magnesium. Yeah, so this is what happened. Okay, so you can see if I draw in the picture, so now the magnesium receive the electron to become Mg. Yeah, Mg2 plus receive electron to become Mg. Just now the metal donate electron. Okay, just now the metal, okay, donate away the electron in order to become metal ion. Okay, so these two process is happen at the same time. Okay, so I show you another one more diagram. Let me use another diagram for demonstration. Okay, let's say, so no worry, you don't need to know how to draw this diagram, you just need to know what is happened. Okay, let's say we have a piece of aluminium, okay, and also solution. The solution got aluminium ion. So here two process is happening. The aluminium metal will donate electron. The aluminium metal will donate electron. So aluminium metal donate electron to become Al3 plus and the 3 electron. Okay, aluminium donate electron to become Al3 plus and 3 electrons. So now aluminium donated the electron. So these are the electron that donated by aluminium. Okay, then at the same time, the aluminium ion in the solution will come over to take away all these electron. Okay, just now the electron donated by aluminium metal will receive by the aluminium ion in the solution. So you will see this. Okay, aluminium ion in the solution will receive electron to become aluminium metal again. So here you can see, okay, two process. Okay, the first process is that the metal is actually donate electron to become ion. Yeah, so the metal actually donate away the electron to become ion. At the same time, you also can see the ion in the solution go to receive the electron in order to become the metal. Yeah, so these two processes is happen at the same time. So please remember, when you have a half cell got one metal and one metal ion, and what they are doing, the metal is donating the electron, okay, and the ion is receiving the electron. Okay, the metal donate the electrons away, and the ion in the solution is receiving the electron. Okay, so these two process happen at the same time. Yeah, these two process happen at the same time. Okay, so now when there is a process of donating and receiving electron, so now what happened is that the electron is moving. Okay, so when, okay, there is a process of donating and also the process of receiving electron. Okay, so as you can see, the metal is donating the electrons, the ion in the solution is receiving the electron. So when constantly got people donate, got people receive the electron. Okay, got somebody donate the electron, got somebody receive the electron. So what happened is that the electron is moving. Okay, so electron is moving. Okay, so when electron is moving, so it will actually produce electricity. So electricity, okay, it's produced. So this is a very important concept that you must understand. Okay, when electron is moving, electricity will be produced. Okay, so here this is a tips or a very important concept. Okay, so the concept is this. Okay, so when electron is moving, So we are able to generate means produce electricity. So if we want to produce electricity, very simple. We need to make sure the electron is moving. How to make sure electron is moving? We must let one substance donate electron and one substance receive electron. Okay? So when there is one substance donate the electron, when there is one substance receive the electron, so the electron now it's moving. Okay? So now the electron it's moving. So when the electron is moving, so we produce electricity. Yeah? So that's why when we come to half cell can produce electricity because of this. Okay, so here let me put a final summary. Okay, so half cell actually can produce the electricity. Okay, because for half cell you can see the metal is actually donating the electron, and then the metal ion in the solution, the metal ion that we found in the solution is actually receive electron. Okay, so in half cell there's somebody donate electron, there's somebody receive electron. That's why half cell can produce electricity. Okay, so the amount of electricity. So now we know already half cell produce electric. Okay, so how many electric it produces? So the amount of electricity actually produced by half cell. So today, if we want to know half cell can produce how many electricity, that is called standard electrode potential. Okay, that is called standard electrode potential. As simple as that. Yeah. So standard electrode potential is actually the amount of electricity produces in a half cell. Okay, so why the half cell can produce electricity? Because the half cell can donate electron and receive electron at the same time. Okay, so if today, which we'll learn later, if we put a piece of zinc and then in a zinc ion, so we already have a half cell. If I say this half cell produce 7.3 watt, so this 7.3 watt is the amount of electricity produced by the zinc half cell. So this 7.3 watt is the standard electrode potential of the zinc half cell. So that is what you need to know. Okay, standard electrode potential is the amount of electricity produced by a half cell. Yeah, so that is what you need to know. All right, so hopefully now all of you understand a little bit what do we mean by standard electrode potential. So let me make a very quick 1-minute summary before I move on and teach you something else. Okay, so far for the first 20 minutes in this lesson, we learned a concept of half cell. So what is half cell? Half cell is formed by a metal and metal ion. If we take a metal, put into a solution, must be solution, cannot be gas, cannot be solid, must be a solution. If we have a metal, put in a solution that got metal ion, we have a half cell. So remember, the metal and the metal ion in the half cell must be the same. If we use aluminium metal, the solution must be aluminium ion. If we use a zinc metal, the solution must be zinc ion, must be the same. So we know that in the half cell, what is happening? Two processes. So the metal will donate the electron. The metal will donate the electron, and the metal ion in the solution will receive the electron. Okay, so this fella donate electron, this fella receive electron. So when there are somebody donate electron, when there are somebody receive electron, so donate go to receive, electron it's moving. So when electron is moving, it produces electricity. electricity. It produces electricity. So the electricity produced by the half cell is called standard electrode potential. Okay, so standard electrode potential is the amount of electricity produced in a half cell. Alright guys, now we already understand that the half cell will produce electricity. Okay, so now we understand that. Okay, so we know that the half cell is actually produce electricity. Okay, the half cell will produce electricity. Okay, and the amount is, and the electricity produces, we call it as standard electrode potential. So now we already know half cell will produce electricity, but how much? Okay, how much is the electric? How to know is, you know, whether just now I showed the diagram 7 volt, 2 volt, 11 volt. How to know how much? Okay, so just now we only know half cell produce electric, but how much electricity is produced? Okay, so the problem is, okay, the problem now is, how are we going to do a measurement? Macam mana kita nak mengukur? Macam mana kita nak mengukur atau menilai? How to measure? Okay, how to measure the amount of electricity? How to measure the amount of electricity that is actually produced by the half cell? Okay, so we know already the half cell produce electric, but how much? So how much? So this is the solution. So in order to measure, so to measure the standard electrode potential, so to measure standard electrode potential, okay, recall back, what is standard electrode potential? The amount of electric produced by half cell. So standard electrode potential is actually the amount of electricity, okay, the amount of electricity produced by the half cell. Alright, so in order to measure the standard electrode potential, so we must do this. Okay, we must go to connect two things together. Okay, we must connect half cell that we want. Okay, we must connect the half cell to a very special thing. This special thing is called standard hydrogen electrode. Okay, so standard hydrogen electrode. So that's it. So today, whenever we want to know how many electric we have in the half cell, we must take the half cell, go to connect to a standard hydrogen electrode. Standard hydrogen electrode, in some of the book, they use a short form SHE. Okay, S is standard, H is hydrogen, E is electrode. Standard hydrogen electrode. So when you see SHE in some of the reference book or textbook, they are referred to standard hydrogen electrode. Okay, so now the next thing is that you must be able to know how to draw. Okay, you must know how to draw the standard hydrogen electrode. Okay, so let me show you what is standard hydrogen electrode. What is standard hydrogen electrode and how to draw? Okay, and how to draw the standard hydrogen electrode. Okay, so you guys must understand this very well. You must be able to understand what is the standard hydrogen electrode and how to draw the standard hydrogen electrode. These two things both you must know. Yeah, you must know. Alright, so I want you to understand this. Okay, I want you to understand that hydrogen can appear in two possible way. Yeah, I want you to understand that hydrogen can appear in two form. Okay, so this is a tips. Okay, this is a tips, or we don't call it tips, I call it side notes. Okay, so I want you to understand that, okay, hydrogen in SPM appear in two forms. Okay, there are two forms, there are two format you need to know for hydrogen. So the first form is hydrogen gas, H2. Okay, hydrogen can appear in a gas form, H2. Second one, hydrogen can appear as H plus ion. Okay, hydrogen can appear as H plus ion. H plus ion is in a solution form. Okay, so for SPM, hydrogen only appear in two form. One is a gas form, which is H2. Another one is solution form, H plus. They won't give you hydrogen in a solid form. Yeah, you won't see hydrogen in a solid form. Okay, so hydrogen in a gas must be H2. Hydrogen in a solution or liquid, it must be H plus. Okay, so these are two forms of hydrogen that you need to know for your SPM. Okay, so after we understand hydrogen appear in two form, we can draw our SHE. So this is SHE drawing. So remember, SHE stand for standard hydrogen electrode. So when we have a solution, we need a container. When we have a solution, we need a container. So we draw a beaker. Yeah, we just draw a beaker. So this beaker is the container. So this beaker inside got solution. So the solution got H plus ion. So here we have H plus ion. Okay, we have H plus ion in the solution. So after that, we have another form of hydrogen, which is hydrogen gas. So hydrogen gas, common sense, if you put hydrogen gas here, the hydrogen gas will run away. Okay, if you put the hydrogen gas will escape. It will run away. Yeah, it will actually run away. So how to make sure the hydrogen don't run away? So to make sure hydrogen don't run away, we need to modify. We need to put in this. So let me draw the picture. Look at the picture, please. So we need to use a tube. Okay, we use a test tube like this. Okay, this is a test tube. The test tube, we make it terbalik. Yeah, so this is the inverted test tube. The test tube, we make it terbalik. Yeah, so this test tube, we must open a hole. We must open a hole. So you can open the hole on the right hand side like this. Okay, you can open the hole on the right hand side like this, or you can open the hole on the left hand side also can. Like this is the test tube. Open the hole. Okay, and then yeah, this is the one. Okay, so you can let the hole to be on the left, or you can let the hole to be on the right. Okay, so why you need a hole? Why the test tube need to open a hole? Because the hole will allow us to put in the gas. Okay, so this hole will allow us to put in the hydrogen gas. Okay, so we will let the hydrogen gas to flow into the tube. Yeah, we let the hydrogen gas flow into the tube. Okay, so that's why we need the hole. So if we don't have the hole, the hydrogen gas cannot go in. Yeah, the hydrogen gas cannot go in. So this is something very, very important. Yeah, so now we already know the drawing here. Okay, so now let me finish it. So remember, here have a solution. So the solution here is the H plus ion. Okay, so now when we have the standard hydrogen, you can see the name SHE. We call it SHE. So SHE is standard hydrogen electrode. So hydrogen, we already have it. SHE, we already have hydrogen. But what about electrode? So what about electrode? Okay, so just now when we have a metal half cell, it's easy. So when we have metal half cell, the electrode here is the metal. Let's say if we want a zinc half cell, we use a zinc electrode. If we want a copper half cell, we use a copper electrode. If we want to use an aluminium half cell, we use aluminium electrode. It's easy. But now as you can see here, hydrogen half cell, can we draw a piece of the electrode here? Draw a piece of electrode and tell people this electrode is hydrogen? No way, because we know hydrogen is not appear in a solid form, right? Hydrogen only appear in a solution form and a gas form. So if you want an electrode, there's no way we can use hydrogen electrode. So that's why for SHE, since we don't have hydrogen electrode, we will use a special material. This special material, you use a small box to draw. Okay, you use a small box to draw. This box, it's called platinum. So this is platinum electrode. So please be careful. So in standard hydrogen electrode, the electrode we use is platinum. We use platinum. We don't use the metal. Yeah, we don't use magnesium, zinc, or whatever. We use platinum. Yeah, and when we draw platinum, we draw a small size. We don't draw like this. We don't draw a very big platinum like this. We draw a very small size of platinum will do. Why? Because platinum is very expensive. For your information, platinum is very expensive. So we don't use a big pieces, because if we use a big pieces, the cost is very, very high. It has very high cost if you use a big piece. So we only use a very small pieces here. Yeah, we just use a very small piece will do. Yeah, because platinum is very expensive. Platinum is very expensive. That's it. Okay. And here, the electrode, you need to draw a wire. Yeah, here you need to draw a wire going up here. Okay, so this is the wire. Okay, so here, this is a wire. Okay, so make sure everyone know how to draw this standard hydrogen electrode. So I draw one more time. Okay, let me draw one more time with you. Okay, so if you want to draw SHE, you must have a beaker. In the beaker, you must have H plus ion. So after that, we must have hydrogen gas. To prevent hydrogen gas to run away, we need a tube. So this tube open a hole, let the hydrogen gas to come in. Okay, so the hole here can open on the left or on the right. Also can. Left or right, both also can. So the H plus ion is the solution. To draw solution, you must draw dotted line. So dotted line is the solution. Yeah. After that, we need a piece of electrode. The electrode is platinum. So draw a small size platinum. Why small size? Because platinum is expensive. So we don't use a big one. So this is platinum, PT. You can write PT or you can name it platinum. Okay, and this platinum must connect to wire. So here connect a wire, go out from here. Okay, so this is wire. So make sure everyone know how to draw. Make sure everyone know how to draw your SHE. Must know how to draw SHE. Okay, so now let's do the final touch already. Okay, so now we already know that. Okay, standard hydrogen electrode. Okay, so standard hydrogen electrode. Okay, what we know so far. So standard hydrogen electrode is a special types of the electrode. So the electrode we go to use platinum. Hydrogen appear in two forms, hydrogen gas and hydrogen ion. Yeah. So we already know this. So the last thing we need to know, it's called standard. Okay. What do we mean by standard? Okay. So standard is something like this. Okay. So we need to set a rules, okay, just like in physics. So in physics, we set a rules by SI. We learn about SI unit. SI unit say that the whole world, for the whole world, the mass, they go to use kilo. For the whole world, the electric, they go to use ampere. For the whole world, the length, okay, the length, they use meter. So why we need to standardize? Why we need to make it standard? So it's easier. You don't want like this. One country go to use meter to measure. Another one country go to use its own unit. Like for example, okay, it go to use a unit called yard. Okay. Another one more country use a unit called stone. So very hard. It's very, very hard to measure. So we don't want that. Yeah. Same thing. One country use kilogram, another country use pounds. Okay. So it will be very hard to communicate. So it will be easy if everyone using the same rules. Okay. If everyone use the same rules. Okay. Same standard. Then only fair. Okay. Then only fair. Huh? Okay. So in order to measure the standard electrode potential, in order to measure the standard electrode potential, okay, all the scientists, they actually agree to follow. All the scientists agree to follow, okay, one common standard condition. So all the scientists, they agree on one standard condition. Okay. So in chemistry, when you say standard condition, you have to know about 4 items here. There are 4 things you need to know. Huh? So when we say standard condition, so there are total 4 things you need to know. So the temperature. Okay, so in order to measure the standard electrode potential, the temperature must be 25 degrees Celsius. So if you do the measurement, okay, if you do the experiment at 50 degrees Celsius, that is not a standard condition. If you do the experiment at 74 degrees Celsius, that is not a standard condition. You must carry out the experiment at 25 degrees Celsius. Then only we call it a standard condition. 25 degrees Celsius also can be written as 298 Kelvin. You learn this in physics. 25 degree plus 273. Okay, so now you can change degree Celsius to become Kelvin, which is 298 Kelvin. This is what you learn in physics. Yeah. All right. So temperature is 25 degrees Celsius, or we call 298 Kelvin. So the next thing is the pressure. Okay. So the pressure, we will use 1 atm. Okay, 1 atmospheric pressure. What it means by 1 atmospheric pressure? 1 atmospheric pressure is the normal pressure, like now in our room. Okay, your current room, the pressure is 1 atm. Okay, atm means atmospheric pressure. Yeah, 1 atm. Okay, so if you don't want to use atm, you also can use 101 kilopascal. You can use 101 kilopascal also can. Yeah. But normally we use atm. Okay, in SPM, normally temperature we use 25. We seldom use Kelvin in chemistry. For pressure, normally we use atm. We seldom use kilopascal in chemistry. But even you write, it's okay, it's acceptable. Okay, the next thing is the concentration. So concentration. Concentration is always referred to the solution. Okay, the solution. Okay, so for solution, the concentration, we learn about concentration back in your Form 4, Chapter 6. If you forget, please refer back to Form 4, Chapter 6, concentration. So how many things you have in a solution. If the solution inside got many things, it's concentrated. If the solution inside got very little things, it's diluted. Yeah, so that is called concentration. So concentration, the unit is mole per dm cube. Mole per dm cube. Okay, mole per dm cube is the unit for concentration. Concentration sometimes they also can call molarity. Okay, we also can call it as molarity lah. Okay, so what is the standard concentration? So the standard concentration is 1. So if today we want to measure the what we call that standard electrode potential, we must make sure the solution concentration is 1 mole per dm cube. So if the concentration is 1 mole per dm cube, that is standard condition. If let's say the concentration is 4 mole per dm cube, then this is not a standard condition. Yeah. So remember, if you want to measure the amount of electricity produces by the half cell, we need to carry out under standard condition. Standard temperature, 25 degrees Celsius. Standard pressure, 1 atm. Standard concentration, 1 mole per dm cube. 1 mole per dm cube, sometime in the book, they write it as 1. So the mole per dm cube, they can use one letter to simplify. The mole per dm cube, sometimes they use one letter to simplify. They write 1m. So in chemistry, when you see m means big M, big capital M, so it means that it is molarity. So molarity, the unit is mole per dm cube. So example, today I have a solution. I see the solution, they put 7m here. So 7m means that the concentration is 7. The m is mole per dm cube. So m, it's the short form for mole per dm cube, which represent concentration. Yeah. So this is something that you have to be very careful. Okay. All right. So now we already have 3. So the last thing is the electrode. Okay. The electrode. So when we want to measure the standard electrode potential, so the electrode must use platinum. Just now, as you can see, I draw the platinum electrode in the SHE, standard hydrogen electrode. Must be platinum, cannot use other, cannot use copper, cannot use zinc here, cannot. If you draw SHE, the electrode must be platinum. So this is the standard condition that you must know. Yeah, standard temperature, how much? Standard pressure, how much? Standard concentration, how much? Standard electrode, how much? Okay. All right. So now let me show you 2 examples here. Okay. So example number 1. Okay. So example number 1. So now we need to draw, okay, the apparatus setup. Apparatus setup means diagram. Okay. Apparatus setup diagram. So draw the diagram, okay, to measure. Okay, we want to draw the diagram to measure the standard electrode potential. Okay, we want to measure the standard electrode potential for a zinc half cell. So we want to know how much electricity is actually produced by a zinc half cell. So how to do it? First of all, you can draw a zinc half cell first. You can draw the zinc half cell. Okay, so the zinc half cell. So how to draw a zinc half cell? Half cell must have a metal and a metal ion. You must have a metal and a metal ion. So we have to draw a zinc metal and zinc ion. So draw a piece of zinc. Okay, draw a piece of zinc first. Sorry. Okay, draw a piece of zinc. Okay, zinc can draw in a bigger piece because zinc is cheap. You can use a big piece. Only platinum need to draw small one. So zinc must put in a solution. Because remember, half cell must have a metal and a solution. Half cell, we must have a metal and a solution. Okay, so the solution. So to draw the solution here, we must have a dotted line. So dotted line. So solution, Zn 2 plus. In the solution, we must have the ion. Because here got charge, we put the word ion. Okay. Alright. So here, settle already. So now, remember, if you want to measure standard electrode potential, you need to connect the half cell to somebody else. Look back something we learned just now. Alright. So in order to measure the standard electrode potential, we must connect our half cell to SHE. So we must draw SHE. We must draw standard hydrogen electrode. So let's draw a standard hydrogen electrode here. So here we will draw a standard hydrogen electrode. So to draw standard hydrogen electrode, so we draw another beaker. So after that, in the beaker, we have H plus ion in the beaker. So H plus ion is solution, we need dotted line. So hydrogen also can be hydrogen gas. So hydrogen gas, don't want to let it run away, so you must have a tube with opening. Yeah, so this is a tube with opening. So you let the hydrogen gas to come in. So this is hydrogen gas. Okay, so here we let the hydrogen gas to come in. Okay, so for standard hydrogen electrode, the electrode, standard hydrogen electrode, the electrode must be platinum. So we draw a small piece of platinum here. So this is a piece of PT. PT stand for platinum. PT, platinum. Yeah. So then, don't forget you must have a wire. Okay, so now settle. So here we must draw this layer. So if you don't draw this, you don't know it's a solution. Okay. So now we will do the final touch. So some very important final touch. If here got wire, so here must also have wire. Then only can connect ma. Wire and wire is connect ma. If only one side got wire, okay. If let's say only one side got wire, one side don't have, cannot connect. So here you must connect a wire. So you draw a wire like this, wire and wire. So they will connect. Okay. So remember, now we want to measure the electric. So we want to measure the amount of electric produces. So to measure the amount of electric, here you have to draw a special device, a circle, and put a V. So this is a wattmeter. Yeah, so this is a wattmeter. So this wattmeter will help us to measure how many electric. Example, later you can see or inside here, 4.2 watt. Then you know already the zinc half cell produce 4.2 watt. Yeah. So that's it. Okay. So the wattmeter will tell you how many electric produces by the half cell. How many electric produced by the half cell. Yeah. So this diagram still need a final touch, because as you can see here there is a gap. So when there is a gap, the electric cannot pass through one. Just like when you learn back in your PT3 science. You see, when you want to have a circuit, this is a battery, this is a bulb. Okay. If we have something like this, the bulb cannot light up one. The bulbs will not light up. Okay, because here you have a gap. So normally for the gap, what they do, they put in a switch. They put a switch. So you must make sure the switch is closed. Okay, only when the switch is closed, when the whole thing is closed, then only the electric can flow, right? Then only the electric can flow. Okay, when the electric is flow, then only the bulb will light up. Okay, so now same thing here. Now as you can see, if electric go from here, go to here, go to here, go to here, cannot, because this electric, there's no way it can go back to here, because you must go back, then only you can complete the whole electric cycle. Okay, so what you should do here is that, okay, you should go to put a special material. So here we will put a special material like this. Just draw something like this, but this is not a wire. This blue color is not a wire. This is called a salt bridge. Okay, and we learned about salt bridge in YouTube. So this is a salt bridge. So salt bridge, okay, will allow us to complete the circuit. Okay, so salt bridge, if they love to ask you the question, so what is the function of the salt bridge? Okay, we learned about function of the salt bridge back in YouTube question. Okay, they will allow the ions. You will let the ion to pass through. Okay, you let the ion to pass through the bridge. Why you want to let the ion to pass through the bridge? In order to complete the electric circuit. Complete electric circuit means conduct electricity. So this is the function for the salt bridge that you need to know. Okay, allow the ion to pass through. So you can see once you put the salt bridge, electric can go from here to here to here, come to here, go here, going back, come back to here. So you can see now we have one whole cycle already. So when we have one whole cycle, then only we have electric. Yeah, so that's it. So you must know how to draw this diagram. Yeah, so if you want to measure the electric of the half cell, we call it as standard electrode potential. How to do that? Take your half cell, connect to SHE. Take your half cell, connect to SHE. So when you connect to SHE, there is electric already. So you must connect using a wattmeter so that you can find out how many electric. Without wattmeter, we will not be able to know how many electric is produces. And you must put a salt bridge, because without the salt bridge, it's just like your electric circuit without a switch. Okay, if you don't have the salt bridge, you don't have this switch. If you don't have the salt bridge, you don't have the switch. If you don't have a switch, here got empty gap. So this empty gap, electric cannot pass through one. Okay, so make sure you must have a salt bridge. Okay, so this is very important. And one more last thing, because this experiment is conducted under, as you can see, this is standard electrode potential. So standard electrode potential, you must have standard condition. You must label your standard condition. So this standard condition, you must label. How you label the standard condition? So let me show you. Okay, so for solution, you must use standard concentration. The solution, you must label the standard concentration. So the standard concentration is 1 m. Okay, so it's 1 mole per dm3. Okay, this is 1 mole per dm3. Okay, 1 mole per dm3. If you don't want to write 1 mole per dm3, you can write 1 m. Okay, no problem. It's acceptable. So same thing on the right hand side, hydrogen ion, also solution. Solution must use standard concentration. Okay, must use standard concentration, which is 1 mole per dm3 as well. So here also 1 mole per dm3. Okay, so what else we need to label? Okay, this whole experiment must be carried out at standard temperature 25 degrees Celsius. So here you don't need to label lah. You can just simply put a words on top here. You can just write temperature equal to 25 degrees Celsius. You can just write temperature equal to 25 degrees Celsius, or you can write 298 Kelvin, up to you lah. Yeah. So after that, because we have a gas got pressure. So standard pressure, it's 1 atm, or we call 101 kilopascal. But I prefer you all to use atm. Okay, if possible, use degree Celsius, use atm. Okay, better. Okay, we seldom use Kelvin, we seldom use kilopascal actually for chemistry. Okay, so Kelvin and kilopascal is more in physics lah. Okay, so here, because we have gas must have pressure 1 atm. Yeah, so that's it. So now we have all the standard condition already. You see, standard temperature 25, standard pressure 1 atm, standard concentration 1 mole per dm cube, standard electrode platinum. Okay, so you must have 4 things, then only you can call it a standard condition. Yeah, so this is what you need to know. So make sure you know how to draw the diagram. Okay, okay, for the standard electrode potential. Yeah, so this is the one. Okay, now, so I would like you to pause the video and try to draw this on your own. So this one is your self-test. Okay, so let's do a very quick self-test here. You can pause the video and try to do these questions on your own. Okay, so now you need to draw the apparatus setup. So again, apparatus setup means diagram. Okay, so you can try to draw the diagram. Okay, this diagram is used to measure the standard electrode potential. Okay, you can use the diagram to measure the standard electrode potential. Okay, for, okay, let's say now I want a half cell called aluminium. Okay, so I draw aluminium half cell. Okay, all right. So guys, feel free to pause the video. Try to spend about 3 to 5 minutes to draw it first. Then only you counter check the answer. So how to counter check the answer here? Okay, so if you are done, you can try to counter check the answer. So we want to have aluminium half cell. So aluminium half cell, let's draw it. Okay guys, not to say the half cell must draw on the left. Just now I draw the zinc half cell on the left, not a must. So some people say, sir, can we draw the half cell on the right? No problem. Let's say for this question, I draw the half cell on the right. Okay, let's say for this question, I draw the half cell on the right. It's okay one, left or right, it doesn't matter. So let's say I draw aluminium half cell on the right. So to draw aluminium half cell must have a metal and metal ion. Half cell must have metal and metal ion. So we need aluminium metal and aluminium ion. Okay, so let's draw it. So we draw a piece of aluminium metal, put in a solution. So to put solution, we must have a beaker. So your beaker inside have solution. Solution must draw dotted line. So the solution is aluminium ion. Aluminium ion Al3+. Okay, because here got charge, put the word ion, aluminium ion. Okay, so now we draw the aluminium half cell already. So remember, if you want to measure the amount of electric, you must connect your half cell to a SHE, standard hydrogen electrode. Always remember, if you only have half cell, there is no way you can measure the electric. You won't be able to know how many electric you have if you never connect your half cell to SHE. So always connect your half cell to SHE. Okay, so let's connect to SHE. Okay, standard hydrogen electrode. So here we need to draw standard hydrogen electrode. So we draw a beaker. So on the beaker here, so inside you must have hydrogen ion. Okay, so after that we know hydrogen can also be hydrogen gas. So hydrogen gas, don't want to let it run away, use a tube. Okay, tube terbalik, invert it. So the tube here put in the gas, hydrogen gas. Okay, so for standard hydrogen electrode, we must use platinum as the electrode. So draw a small piece, because platinum is expensive. Use a small piece will do. PT, platinum, small piece. So platinum expensive, you use small piece. Aluminium is cheap, can use a big piece. Alright, so then what happened? Remember, hydrogen ion is a solution. Solution must draw like this and dotted line. Okay, that's it. So now we need to connect them together already. So to connect them together, we need to use wire. So draw a wire, go up, draw a wire, go up. So these two wires need to connect. To measure the amount of electric, to know how many electric we can measure, we need a voltmeter. Use a voltmeter to measure the amount of electric. Yeah, and don't to forget here got a gap. So got a gap means that we have a wire like here, open up, got wire, don't want. So we need to put in a switch. So in chemistry, we don't put a switch here, we put a salt bridge. Okay, we put a salt bridge. So how to draw a salt bridge here? So salt bridge, you can just draw something like this. Okay, just draw here, go to here, like this. Okay, and then label it salt bridge. Okay, so now we have everything already. And don't forget, because we want to measure standard, okay, electrode potential, standard. So standard, you must put in your standard condition. So standard condition start with temperature. So write any place in the diagram, write temperature. So temperature must be carried out at 25 degrees Celsius. Okay, standard pressure. So pressure applicable for gas. So when we have gas, we need standard pressure 1 atm, standard pressure. Okay. Standard electrode, platinum, we have it already. Standard concentration. So when we have solution, we need concentration. So the concentration is 1 mole per dm cube. 1 mole per dm cube. So if you don't want to write 1 mole per dm cube, you can write 1 m. You can write 1 m. It's okay one. Yeah, m or mole per dm cube, both acceptable. So this is how you draw the diagram. So make sure you know how to draw the diagram for standard electrode potential. This is very, very important. Make sure you know how to draw the diagram, and you must able to label. Okay, you not only draw the diagram, you must be able to label. Okay, so here let me make a summary. So let me make a final summary for you. Okay, so you must make sure that you have this few skill. Okay, you must understand that in order to measure the standard electrode potential, so today if you want to measure the standard electrode potential, so you must make sure that you connect your half cell. You must always take your half cell, connect to standard hydrogen electrode. Okay, you must be able to connect your half cell to standard hydrogen electrode. Standard hydrogen electrode, we also can call it SHE lah. Okay, so that's the first thing you must able to master until now. Okay, so the next thing, okay, the next thing that you must be able to master is that you must able to draw a diagram. Okay, you must able to draw a diagram. So the diagram, you must also have a label. Okay, you must be able to draw a diagram with the label. Okay, so what is the label? Okay, the label is the label of standard condition. Okay, you must be able to label your standard temperature. You must be able to label your standard pressure, your standard concentration, and also your standard platinum electrode. So this is a very important skill that you must know until this moment, based on whatever thing we learned so far for today's lesson. Yeah, so this is a checklist. If you don't know this, make sure you revise back. You check back all the concept. Make sure you fully understand it. Okay, so I go very, very slow because, like what I say, this concept can be very hard and very confusing if you don't understand it. Okay? If you don't understand it, it can be very, very confusing. Okay, and when you draw the diagram, okay, don't forget about this. When you draw the diagram, don't forget about the salt bridge. When you draw a diagram, because many people, when they draw the diagram, they always forget to draw the salt bridge. Okay, and don't forget to draw your wattmeter. Okay, many students, they forget to draw the salt bridge, they forget to draw the wattmeter. Yeah, so this is something that you must be careful. Okay, you must always double check to make sure that your diagram in the end must have wattmeter, your diagram in the end must have a salt bridge. Okay, so that is what you need to know.